Welcome to The Explainer. Today, we're diving into one of the biggest mysteries in the entire cosmos, and we're going to do it by looking at the strange, almost impossible behavior of just one single spinning galaxy.
So let's jump right in. When you look at a galaxy like this one, you see these stars way out on the edge, and they are moving at incredible speeds. I mean, they're going so fast they should just fling themselves right off into deep space. It's like they're breaking the laws of gravity as we know them, and that's a fascinating puzzle.
And this isn't just a one-off thing. Back in the 1970s, an astronomer named Vera Rubin, she confirmed this bizarre motion in galaxy after galaxy. What she found was this massive, undeniable gap between how our theories said galaxies should be spinning and how they actually are.
And this right here shows you just how strange it is. You'd expect stars farther out to move slower, right? Just like how Pluto moves way slower than Mercury in our solar system. That's what all the visible matter tells us should happen. But nope. What Rubin saw was a flat line. The stars on the very edge were moving just as fast as the stars near the core. This was a groundbreaking discovery, and it screamed that there had to be a huge amount of unseen mass out there. And, this idea of missing mass wasn't totally new. Decades before Rubin, an astronomer named Fritz Zwicky was looking at whole clusters of galaxies and basically saw the same problem. He realized that based on the light they were putting out, there just wasn't enough gravity to hold these giant clusters together. They should have flown apart billions of years ago. So physicists came up with a pretty wild solution. What if our galaxy isn't just the bright, shiny stuff we can see? What if the whole thing is sitting inside an enormous, invisible halo of matter that's providing all that extra gravitational glue? And they gave this stuff a name: dark matter. Now, this isn't just empty space we're talking about. It's a proposed type of matter that has mass, so it has gravity, but it doesn't interact with light at all. Doesn't absorb it, doesn't reflect it, doesn't emit it. It's totally invisible to all of our telescopes.
Now, for this whole invisible halo idea to actually work, dark matter needs to have a very specific set of skills. It has to be dark, obviously. It has to have gravity. It needs to be incredibly stable, not decaying over cosmic time. And, this is key, it can't really interact with itself or with normal matter, except for gravity. It's got to be one of the most elusive things you can possibly imagine.
We have another piece of evidence too, and it's called gravitational lensing. The idea is that the immense gravity of this giant dark matter halo should act like a lens in space, actually bending the light that comes from galaxies far behind it. And guess what? That's exactly what we see. The amount of bending is way more than the visible matter can explain, which points us right back to that massive invisible halo. So let's zoom out a bit, because this invisible stuff isn't just keeping individual galaxies from flying apart. It seems to be the main architect of the entire universe. To understand that, we have to look all the way back to the universe's baby picture, the cosmic microwave background. This is literally the afterglow of the Big Bang, the very first light that was ever able to travel freely. And printed on this ancient light are the tiny seeds of everything that would ever come to be. Now, when scientists studied the tiny temperature wiggles in this light, they found a really startling imbalance. To get from those little seeds to the huge galaxies and clusters we have today, there has to be about 5 times more dark matter than all the normal matter. That's all the atoms in the whole universe combined.
Think of it like this. Without this invisible scaffolding, normal matter would have had a really hard time clumping together. Dark matter created the gravitational framework, the cosmic web that pulled regular matter into these dense patches that eventually lit up as the first stars and galaxies. Without it, our universe might just be a vast, uniform, and very empty place.
But how can we be so sure dark matter is a real thing and not just, a sign that we've got gravity wrong on these huge scales? Well, a spectacular cosmic car crash gives us what a lot of people call the smoking gun.
So say hello to the bullet cluster. This isn't just one cluster of galaxies, it's 2 smashing into each other at unbelievable speeds. It's a natural experiment on a scale we could never dream of creating, and it gives us this perfect snapshot of how different kinds of matter behave. So what happens during this mega collision? Well, the normal matter, which is mostly hot gas, it all slams into itself, slows down, and creates this big shockwave. But the dark matter, which barely interacts with anything, it should just sail right through itself and through all that gas, like a ghost passing through a wall. And here's the kicker. We can use that gravitational lensing trick again to map where all the mass is. And the map is clear. Most of the mass is not with the hot, glowing gas.
It's sailed right on through, separating completely from the ordinary matter. This is just incredibly powerful direct evidence that dark matter is a real, separate ingredient in our universe.
But still, some physicists aren't totally convinced. They ask a pretty compelling question. What if we don't need missing matter at all? What if our theory of gravity is what's missing something?
This alternative idea is called MOND, which stands for Modified Newtonian Dynamics. And it basically suggests that way out on the edges of galaxies, where gravity gets incredibly weak, maybe it just behaves differently. Maybe it gets a little stronger than we expect. And if that's true, it could explain those fast-moving stars without any need for dark matter at all.
And there's actually a great historical parallel for this. For years, astronomers thought Mercury's weird orbit was being caused by a phantom planet they called Vulcan. But Vulcan didn't exist. The real answer was that Newton's gravity was incomplete, and Einstein's general relativity explained the orbit perfectly. So the question is, could dark matter be our modern-day Vulcan?
So where does all this evidence leave us? Well, while MOND does a pretty good job of explaining how single galaxies spin, it starts to fall apart when you look at bigger scales.
MOND really has no good explanation for the bullet cluster. There's just no mechanism in that theory that can separate the center of mass from the center of the visible stuff during a collision like that. And that observation brings us right back to dark matter as the best explanation for what we see all across the cosmos.
And this really gets to the incredible place modern physics is at right now. We're facing this profound choice. Either 85% of all the matter in our universe is made of some mysterious, invisible stuff we've never ever detected, or one of the most fundamental theories of nature is just wrong. So we are left with one of the single biggest unanswered questions in all of science. Dark matter is what you'd call a known unknown. All the evidence tells us something massive and invisible is out there, but we have absolutely no idea what it is. What new physics are we going to uncover when we finally solve this cosmic mystery? Because answering that, it will totally redefine our understanding of everything.